Hello. Today we will present the Multithreading and Concurrency, a train timetable scheduler. This is our team member. Table of content. 1. Background on threads, multithreading and concurrency. 2. Retrieve, edit, create, manipulate multithreading operations in Java. 3. The life cycle of threads. For the common issues of threading in the operating system context.
About thread. Thread is the independent units of execution within a process, sharing memory and resources. Threads operate as independent units of execution within a process, sharing memory and resources to achieve lightweight multitasking and streamlined communication. Next, multithreading is executing multiple threads concurrently within a single process. The benefits of multithreading is enhanced responsiveness. Background tasks run smoothly, keeping your applications interactive and responsive. Better resource utilization. Tap into the full potential of your hardware by effectively using multiple CPU resources. Next is increased throughput. Accomplish more tasks in less time through parallel execution of independent threads. Last but not least, concurrency is a simultaneous execution of multiple tasks or processes. Through approaches like multithreading, multiprocessing, and asynchronous programming, concurrency enables efficient resource utilization to maximize hardware capabilities for optimal performance and enhance user experience to deliver seamless responsiveness and smooth interactions. Also, it can improve scalability by handling growing workloads gracefully and effortlessly.
Hi, I am Nur Aziemah Binti Razali. So I will present the codes and the demo system. First, retrieve, edit, create, manipulate multithreading operation in Java. First, I have write two code here. Create and start thread. I use run used to define the action for a thread. So you see this the run code, the new runnable. Next, for start, initiates the execution of the threads. So here is the start. Next, thread manipulation. Sleep delays the execution of a thread for a specified period. So in this code, I have write thread.sleep in 5 seconds here. Next, join. Wait for a thread to complete its execution before moving. So in this application, I'm using I will execute thread th0 first, and after th0 first done executing, the other thread will join after the th0 is done. Then set priority, adjust the priority of the thread. So before start the thread, in here I write the code to set the priority. For example, for this thread 0, I set it for thread max priority. Next, retrieving thread information. Get name, return the name of the thread. Get ID, retrieve the unique identifier of the thread. Get priority, provides the priority level of the thread. So this is the code. We can see here, thread.current thread get name, thread.current thread get ID, thread.current thread get priority. Next are the program flow. First, we have start, and the first function we load flag UI. This will load the interface, user interface. Next, connect. This function will initiate connection to database. Then next, execution of 6 threads asynchronously. So the first thread is timer, to show current timestamp. So this will show the current timestamp in the user interface view. Next, thread th0. First, I set priority max for the th0, start th0. Then it will run update flag, table load. Then the thread will end, and the other 4 thread next will join the execution. So the thread TH1, TH2, TH3 and TH4 will wait first until thread TH0 is done executing. So for the thread TH1, I set priority min for the TH1 then start TH1. So in this thread, I set while the loop is true, it will call table load and sleep for 5 seconds. Next, thread TH2, set priority max for the TH2 start TH2. Then while the loop is true, it will keep call the function is approaching. Then it will sleep 10 seconds. So the is approaching will update the flag that has expected flag. It will update it to approaching flag. Next, thread TH3, set priority norm for the TH3 start TH3. So in the loop, while the loop is true, it will call function is arrival and it will sleep 10 seconds and it will loop back. So for the is arrival function, this function is to update the flag from approaching to arrival. Next, thread TH4, set priority norm for the TH4 start TH4. While the loop is true, it will call is departure function and it will sleep 10 seconds. So the departure function is to update the flag from arrival to departure. Okay, next, so this application will run until the user close the application. So if the user close the application, the program flow will end. Okay, that's all for program flow. Next, I will show you the application output. So this is the user interface for the train scheduler project. This is the current timestamp. It will show. This is run from the background. Next, this is the form to insert new schedule. So next, this is form to find the train. So we need to enter the train number here. Next, this is the table view for current timetable with updated flag. So in the right side, we have log with timestamp to show the thread running in the background. This is the application. So we can see right now we have a train showing here with the flag departed, arrived, and approaching and expected. So we can see it will change. Okay, now the arrived train, before I will change the flag to departed and we will wait for example 2025. This is train number 2025. It will departed at 9:46. So here 9:45 something, we will wait until 9:46 to change the flag to departed. So this train 9:46 already changed the flag to departed, and each time the thread is kept looping, it will show the log here. So for example, I will show you the first log, the first thread. The first thread, it will load the main TH0 thread is completed. This is the log. First, it will run the TH0 first. The TH0 will run one time only. Then after the TH0 done executing, the approaching thread will follow. Next, departure thread, arrival thread, load table. These 4 threads will run synchronously, simultaneously. Also for this thread, this is user interface thread. this current timestamp also will run simultaneously, and this background thread will not disturb this user interface functionality, so the application will not hang. Okay, I will demo to insert schedule 9017. So this is the schedule, so we will wait. Okay, at 9:52 it show the flag, it changed the flag from expected to approaching. Okay, here you can see the thread already execute the arrival. The arrival changed the flag from approaching to arrive. We will wait until 9:55 to see the flag is updated to departed. Okay, so right now the thread number 9017 is have changed the flag to departed in function with thread runnable. First, this is the thread 1 with the name ph0. So as you can see here, I have write the code to show the thread information to the log, and it will execute. It will call the update flag and table load. Next, in the update flag, this will run one time only. So this update flag will update the training flag set where the set flag is the departure time is below the current time, so this will automatically set the flag to departed. Next, thread 2 with the name ph1. So the thread 2 will call the function table load in the loop 5 seconds. So each 5 seconds the loop will execute the table load. So the table load is the function to call the train schedule and show it to the user interface. So this is timer for clock. So as you can see, the clock run as first. This we initialize the timer first with the delay 1 second, and the timer start here. Next, thread 3 with the name ph2. This ph2 first it will show the thread information to the thread, and it will executing the is approaching with the thread sleep 10 seconds. This function will this is the function. It will change the state flag from expected to next thread for TH3. This line of code also to show the thread state thread information to the log, and next it will call its arrival with the thread sleep 10 seconds. So next this is the is arrival function. So this arrival function will will update the state flag approaching to the arrive. Next thread 5 th4. This is the thread function. So the thread will show the thread information to the log, and it will call its departure function and sleep thread sleep 10 seconds. So this departure will update the flag from arrived to departed. This is the thread flow. So first TH0 I set it to the max priority, and the TH0 will start first. Then after the TH0 is finished executing, the other thread will join the flow. So for the TH1 I set it for thread main priority, to the thread main priority. So I will I start the TH1, then TH2 I set it to max priority also, and TH2 start. TH3 I set priority thread non-priority, and TH3 start. TH4 set priority with the non-priority, and TH4 start. Okay, that's all from me. Thank you.
Assalamualaikum and hi, my name is Nur Athira Syafiqah Binti Sotiman, and I will be explaining about life cycle of thread. Threads are fundamental execution within a program that have their own life cycle that details their numerous state and transition during their existence. Threads' behavior and progression during program execution are directly reflected in their life cycle. In general, thread can go to several states such as new state, runnable state, waiting state, time waiting state, and terminated state. So the diagram below shows the example of life cycle of a thread. As you can see, there are 5 states in the thread life cycle, which are new state, runnable state, waiting time state, time waiting state, and terminated state. Let us analyze one by one. So the first one is the new state. When a new state is created, it is called new state. It is the state where the code has not yet been run and executed for a thread in a new thread since it has not been run. So it is often used upon created a thread and initialized with a runnable instance. So moving on to the second state, which are runnable state. In a multi-threaded program, a thread transitions through different states. So invoking the start method, move it from a new to a runnable state where threads are either running or ready to run within specific time frames. So after completing its allotted time, a thread yields the CPU, and during the waiting period, threads remains in a runnable state, forming a queue. So when a thread gains CPU access, it transitions from ready to run to running, typically following a sequence of ready to run to running and back to ready to run. So next, waiting state. So when the main thread uses join method, it enters waiting state, signifying inactivity. So this occurs as the main thread awaits the completion of child threads. So after the child threads finish their task, they notify the main threads, prompting its transition from waiting to an active state. As for time waiting state, in order to prevent starvation, threads enter a time waiting state using a sleep method. So during this period, the thread pauses its execution, and after the specific time elapsed, the thread awakens and continues execution from where it paused. So last but not least, terminated state. When a thread finishes its job, it exits the thread normally. So when a thread terminates, it exits the system. So the thread is no longer functional and considered as dead, and there is no way to revive or reactivate a terminated state. So that's all from me. Thank you.
Okay, I will presenting the common issue of threading in the operating system context. Synchronization and data race issue. First, race condition occur when multiple threads access and modifying share data without proper condition, or multiple threads accessing and modifying share resources concurrently can lead to unpredictable and incorrect result. This is known as race condition, where the outcome depends on the timing of thread execution. This also can lead unpredictable result, data corruption and crashes. For example, two threads incrementing a share counter simultaneously might produce incorrect values. Second, data locks arise when two or more threads circularly wait for resources led by each other, causes indefined program stalling, or when threads depend on each other for resources, a circle depends can arise, preventing any thread from making progress. This is called a deadlock and can render the program unresponsive. For example, thread A holds a lock on resources X and wait for thread Y, while the thread B holds Y and waits for X. Starvation. In certain scheduling scenarios, some threads may never get a chance to run due to other threads constantly occupying the resource. This can lead to unfairness and hinder program execution. Alright, for the next slide. Complex and debugging. Hidden bugs. Multi-thread programs are inherently more complex and can harbor suitable bugs that are difficult to identifying and diagnosing. Second, memory management. Threads share the same memory space as the process, increasing the risk of memory leaks and corruption if not managed properly. Overhead. Spawning and management threading introduce addition overhead for the operating system, potentially impact overall performance. Okay, for the next slide is system specific issue. Fork and execution system calls. The behavior of system calls like forks and execution in the context of multi-thread program can be ambiguous and vary depend on the operation system. Second is signal handling. Deliver signal to specific threads within a process can be challenging. Thread cancellation. Safely terminating a thread while it's executing and can be tricky and leads to data corruption if not done properly.
Multithreading is a powerful programming paradigm that enables concurrent execution of tasks within a single process, providing opportunities for performance improvement and responsiveness in software applications. The highlights of multithreading are concurrency benefits, debugging and troubleshooting, data sharing and protection, and interrupt handling. Thank you.